Alright, we're going to take a look at exponents. First thing we want to do is a couple vocabulary terms here. Exponential form of an expression is used to show repeated multiplication. In general, if b is a real number and n is a positive number, then b is the base and n is the exponent. I think this where can be taken out of there. Integer, the set of whole numbers, both positive and negative. Alright, as well as 0. Okay, so you have all the numbers back, whole numbers, negative whole numbers, back from negative infinity all the way up to 0, 1, 2, 3, etc. Okay? Alright. Now, properties of exponents. Okay? Basically, if you're multiplying two expressions that have the same base, you can add their exponent, and if you're dividing two expressions with the same base, you are subtracting them. It should be pretty much review here. So let's take a look at this. If we have a squared times a to the 5th, that's equal to a to the 2 plus 5, which equals a to the 7th. And here we have we're dividing two expressions with the same base, so we can subtract. So we get y to the 3rd. And those will be our answers using those properties. Okay? If you have a base to a power raised to another power, when we have exponents in this position, we multiply them. So in this case, this is the same as saying x to the 2 times 3 power or x to the 6 power. Okay? Product of a power, here if we're taking if we take a quantity here to a power, what we can do is take each base and multiply that out. Now, part of the reason for that, and I'll explain this when we use it here in this example. We'll do it right now. If I'm cubing 5x to the 4th, really what you're doing is taking 5x to the 4th times itself 3 times. That's what it means to cube something. Okay, so the 5 is going to be cubed because we could rearrange this here to be 5 times 5 times 5 and x to the 4th. I put 3rd there. Times x to the 4th times x to the 4th. Okay, and so you see what we end up doing is cubing the 5 and cubing the x to the 4th. Okay, and we end up with 125 x, and then again, if we multiplied all these out, it would be 4 plus 4 plus 4 power, which would actually end up being x to the 12th. And again, notice that this is 5 cubed times x to the 4th cubed, if you wanted to put it in the form of the product and to a power property. Okay, quotient to a power property basically says that if you're taking a fraction to a power, you can just take the power to the numerator and the denominator. Okay, so if we have p to the 5th to the 4th, p to the 5th over 2 to the 4th, then we can look at that as p to the 5th to the 4th over 2 to the 4th. Okay, and again, exponents in this position, we're going to multiply, so we're going to get p to the 20th over 2 to the 4th, which is 16th power. Or I'm sorry, not 16th power, 16. Alright, there are answers. Last and one of the more important ones here is when we have a negative exponent. Okay, all that means is reciprocal. As a matter of fact, I usually don't even refer to this as a negative power. I'll just say the reciprocal of b to the n power. And that's what we have here. Okay? So whenever you have a negative power, it just means reciprocal. Okay, we're going to put this, our base, under 1. Okay? And notice here, if it's a fraction, it just flips. Okay? Because, that's what would happen if you put that fraction under 1. We'll take a look at that in class. But y to the negative 4th power would be 1 over y to the 4th. And 2 to the negative 7th power. Now, here's something we'll take a look at real quick. That means that this is 2 divided by 1 over d to the 7th. And this is probably from a while ago that you should have learned that when you divide, like I am here in red, by a fraction, dividing by a fraction is the same as multiplying by the reciprocal of a fraction. And so this would be 2 times what is the reciprocal of 1 over d to the 7th? D to the 7th. So this actually equals 2d to the 7th. Okay? In other words, if you have a negative in the denominator of a fraction, a negative exponent, in the denominator, it'll end up going up top. That's what will end up happening. Okay? Alright. And lastly here, any number to the 0 power is 1. Any base to the 0 power is 1. So here we look like we have a little bit of a mess, but really if you look at it, the whole thing is to the 0 power, which means this entire quantity is equal just to 1. Alright? We'll do a couple difficult examples here and then be done. If we were multiplying these two quantities, since this is all multiplication here, I'll write this out. This is really 3 times a times b to the 4th times 4 times a times b to the negative 3rd. And because multiplication is associative, we can multiply these. Everything's multiplied here. We can just multiply these in any order that we want. So I could rearrange this to negative 3 times 4 times a times b to the 4th times b to the negative 3rd. So we get negative 12 a squared b. Okay, because we would add the 4 and the negative 3, which is b to the 1st, and that would be your answer. In the next one here, we would use our a power to a product, and we end up with 2 cubed times x cubed times y squared cubed, or 8 x cubed y to the 6th. Okay? Next one, notice we have a 0 power. That's the first thing that catches my eyes. So I would say 3a times 1. No matter how complex this looks inside here, the whole thing's to the 0 power. So it's going to be 1. So this one just equals 3a. Now here, this is a fraction, and we can go about this by reducing. If you notice, 12 and 4, okay, will reduce. Just 4 divides evenly into 12, so we get 3 over 1 here. We'll have that. And then let's subtract these. So I'm going to end up with 3 times a to the, a to the 3 minus negative 2 power, and b to the negative 4 minus 1 power, which ends up equaling 3a to the 5th, b to the negative 5th. And we usually don't want to write our final answer with a negative exponent, so since this means reciprocal, we would take that to the bottom, and that would be our final answer. Okay? Here, notice we have a reciprocal, so I'm going to take care of that first. So I really have we're going to take care of the reciprocal. Y over 3x squared still. All we did was take care of this little negative right there by flipping what's inside there. After we do that, I can square the top and square the bottom. And using the product to a power rule, we get y squared over 9x to the 4th. Okay. Last one here. is a little tricky because we have a base that's not just a single value, but we can still apply the rules that we have up there. So first off, let's reduce 12 ninths. 12 ninths will reduce to 4/3. Okay? And then we can say, really, that this is x plus y to the 3 minus 1 power, because here's our 1 power. And we get 4/3 x plus y quantity squared, or you could write this as 4x plus y quantity squared over